So this lesson will be about the sum and difference formulas. These are in the front cover of your textbook, and these are some of the last formulas that we didn't know yet. And today's lesson will start with kind of a lengthy discussion about deriving these formulas, and then most of your homework will just be about applying these and understanding how to use them and try to get them memorized. And so that's what we're going to discuss. I want you to go find some colored markers or colored pencils or different colored pens. Grab a few pieces of paper, like maybe 3 pieces of paper. This will take us a little while. I want you to draw 2 unit circles like I have shown with those. We're going to take these 2 unit circles that you already have drawn, and I'm going to draw 2 angles in standard form. And so I'm going to draw an angle. It could have landed anywhere, to be quite honest, but I'm going to have an angle extend from so this angle is going to be in standard form. So the terminal side is going to lie on the positive x-axis, and this red angle is going to be maybe alpha. So we're going to call this alpha. And I'm going to have a second angle, and I'm going to do it in maybe blue. So in blue, I'm going to insert another ray. This will be a different angle, a smaller angle. It could have, both of these angles, they could land anywhere in the unit circle, and later you can practice this again. But for right now, just to make it easy for our picture, I'm going to do this where both of them lie in the first quadrant. Alright, so there's our second angle. I'm going to call that second angle beta. And what we're going to do with these 2 angles is, because this is a unit circle, I'm going to think about the corresponding points when the sides, so the terminal sides, intersect with the unit circle. The initial sides, now that's an easy case. So this point right here, if this is on the unit circle, the radius of the unit circle is 1. And the y value there would of course be 0 because that's on the x-axis. And so this point is the point 1, 0. For the point that I should see right here for the blue angle, now if I call that angle beta, then I don't know the angle. It could be an angle I have memorized, but it might not be, and we want to build a formula for anything. And so what we're going to call that is simply that since x is always assigned a cosine, this will just be cosine of beta, and sine will be the y value, so sine of beta. Now for the red angle, if I'm calling that alpha, then the angle that corresponds to the point that corresponds to the terminal side there would be cosine of alpha, sine of alpha. So I simply have a unit circle, 2 angles drawn. This angle in red I'm calling alpha, the angle in blue I'm calling beta, and I have 3 points labeled. I have the point 1, 0, the point cosine of beta, sine of beta, and cosine of alpha, sine of alpha, between these 2 points. So if I were to draw a line segment, I'm going to do this in green. The line segment between these 2 points, a chord, and I'm trying to draw a straight line segment there, just a simple distance between those 2 points. We're going to go over here to the right, and I'm going to draw a picture that's pretty similar. What we're going to do is take this difference. Now I'm looking right here, this difference between the terminal side of the red angle and the terminal side of the blue angle. This little angle right here. I'm going to take that angle and I'm going to rotate it and draw it in standard form on the right side. So I'm going to do this in purple. You can use whatever you'd like. I'm going to do this in purple, and what this is going to represent is this angle that we had over here. I'm just going to draw this on the right and draw it in standard form. we're just going to call this alpha minus beta. It's simply alpha minus beta because it's just the difference of those two. So again, this little purple region, I've just drawn it in standard form over here. And let's go ahead and do the same thing we did earlier and label these. The x coordinate of that point where it intersects the unit circle would be cosine of alpha minus beta. I don't know what the angle is. I want to build a formula that works for anything, so we're just going to call it the difference of those two, an alpha minus beta. And that represents the ordered pair where the terminal side hits the unit circle and then 1, 0 represents the other. Now this green line segment that we had over here, the distance of that, since this angle all we were doing was rotating it down on the x-axis, it should be the exact distance. I wanted to focus on the green line segment I have between these 2 points between the terminal sides of alpha and beta. And using the distance formula, we get an equation that looks, or a statement that looks something like this. So the distance is always the square root of, and here I have the difference between the x value squared plus the difference between the y value squared. So these were just the 2 points that we had used before. If I expand this part inside and maybe pause the video while you do that, you have a cosine squared of alpha, so you'll have a 2 from the cosine squareds and the sine squareds from the Pythagorean identity, and then this term stays 2 cosine alpha cosine beta and a 2 sine alpha sine beta. Now we can't really simplify it much more than that, so we're going to just pause there and we're going to look at the other picture. Now the other picture, remember, was this angle inside, this interior angle, the difference between the larger angle and the smaller angle, so alpha minus beta, and it was rotated so that it was in standard position. So something kind of like this. We don't know what the angle is, we're just calling it the difference of the two angles. I'm using alpha as my bigger angle, but we could generalize this, or this is generalized and we could use other angles. So again, I want to find the distance of the green line segment. Remember that that's the same green line segment as on the other one because I'm just rotating the angle. So using the distance formula again, I'd have the difference between the x values here squared, difference between the y values, you don't even have to have this minus 0 if you don't want to, and that's squared. So take a minute and expand this. So pause the video while you expand that. And what you should have is something that looks similar to this. Again, you have a cosine squared of an angle and a sine squared. Those match to equal 1. You already had another 1 here, so I'll have a 2 minus this term, cosine alpha minus beta. Now, the term that we have here, it's a little less messy than the last one, but since those are the same green line segments, although the expressions look different, they should actually be equivalent. So I set them equal to each other. This was what was under the square root on the first one. This was what it was under the square root on the second one. Actually, this has a typo, so I take the part that was under the square root on the first one and set it equal to the part that it was under the square root on the second one. You'll notice they both have a 2. So I subtracted 2 from both sides, and everything still had a negative 2 out front, so I divided everything by negative 2, and I got an expression that looks something like this. Now that is much more simplified. Because the right side should have equaled the left side, this is an identity, so this entire expression, these two sides should be equal, and this is called the difference formula for cosine. The difference formula because it's the difference between two angles, using it for cosine, and you'll probably want to memorize this for the rest of the semester. Let's talk about it. You'll notice if it's cosine of alpha minus beta, that negative becomes a plus on the right side. Also, if it's cosine alpha, you're going to take cosine of the first, cosine of the second, and then sine of the first, sine of the second. So the sines stay together here and the cosines stay together. And you might read that out loud a couple times, so pause the video, read that out loud, maybe write it on a note card. This is one that you'll need to use for this homework quite frequently. In fact, all of the other formulas actually come from this formula. We won't use those unit circles again. So why would you use this, you might wonder? If you had cosine of 30 degrees, 45 degrees, 60, I've already asked you to memorize all of those values. But this is going to open the door to many other angles, such as, for instance, what if you had cosine of 15 degrees? I've never asked you to memorize that. I would never ask you to know that value. It's actually kind of a strange value to write in its irrational form. But 15 degrees just happens to be the difference between two angles that you do know values for, 45 degrees and 30 degrees. So if we were to use 45 degrees as my alpha and 30 degrees as my beta, so once you plug those values in, these are values I'll ask you to memorize, or you could get from a unit circle. You can actually calculate that actual value, that exact value. So this would be the exact value. Go ahead and take a minute and check your work. Check that this equals what you have. It might be in a different form. And you could even try on the calculator, type in cosine of 15 degrees in degree form and see if you get the same decimal for all of these. You should. So obviously this is such a messy value. I would never ask you to memorize it. New angles that we were not able to do before. Anytime you can write a number then as the difference of 30 degrees, 45 degrees, 60 degrees, or any of their multiples, then you would be able to evaluate that angle using this formula. Now you might be asking, what if it's a plus? Well, we'll look at the sum formula for cosine. If you had a plus inside, so here you'll see the original formula. If there was a plus inside, then alpha plus beta is the same thing as alpha minus negative beta. So take a minute and look at that. I'm going to use the formula that we've already derived, but I'm going to plug in alpha for alpha and negative beta into the formula for what I had for beta. So this will be my second angle. So I have cosine of the first angle, cosine of the second, plus, because I'm taking a difference here to use that formula, sine of the first, sine of the second. And that looks very familiar. I want you to take a minute and pause the video and look at your even and odd identities. Cosine of negative beta, since cosine is an even function, cosine of negative beta is equal to cosine of beta. Sine of negative beta, since sine is an odd function, is equal to negative sine of beta. And so this changes our sign. You'll notice when there's a plus for cosine, then it gives us a minus on the right side. We still keep the same order. Cosines are together, sines are together. So we could actually write these two formulas together. They're very similar, and often what we'll do, you might remember a plus or minus from the quadratic formula, and this is similar, but it's not that it has two solutions. If you want the difference formula, if this is on top on the left, you're going to choose the plus on the right that's on the top as well. If you want the sum, as I have it written here, since the plus is on the bottom, I choose the minus sign on the right side. So this is just kind of a shorthand way of writing both of those formulas together. Now the sum and difference formulas for sine will actually need to use those two formulas. So if you need to take a minute, get your cofunction identities. We're going to use our cofunction identities. And so we begin with this statement. Sine of an angle is equal to cosine of pi over 2 minus that exact angle. We know that cosine and sine are very similar. Their graphs differ by a translation of pi over 2. And so this is the cofunction identity that I'm using here. Now in the next step, I'm going to distribute this negative and rearrange the terms. So I distribute the negative to get pi over 2 minus alpha minus beta. And then I'm going to group the first two terms together. I know that that seems odd, but bear with me. The reason I'm doing this is because I'm going to use the difference formula for cosine that we worked from the very beginning. And I'm going to use this yellow pi over 2 minus alpha as my alpha, my first angle, and then my beta is my second angle. So plugging these into the formula, I have cosine of the first angle, cosine of the second, plus the sign changes for cosine, sine of the first, sine of the second. And looking again at your cofunction identities, this is actually what we use to do the first line. This is simply sine of alpha, and this is cosine of alpha. And those are because of your cofunction identities. So this one wasn't too bad. Sine of alpha plus beta gives us this formula as we have here. And if I had had sine of alpha minus beta, hardly anything really would have changed. I would have had a subtraction sign. When I distributed the negative, it would have become a positive. An addition sign, addition sign. Now cosine with a sum changes the sign. And so that's why this would be a plus minus. So I start with a plus minus for sine. I end with, that means that sine doesn't change the sign. So keep that in mind. The formula for sine, we do have some differences here. Now my cosines aren't grouped together, so it goes sine of the first, cosine of the second. But if it's a plus, it'll stay a plus, cosine of the first, cosine of the second. And so here are your sum and difference formulas for sine. You will also want to know these formulas and be able to apply them in this section. And lastly, we'll look at tangent. So the sum and difference formulas for tangent. Now these, I'll be honest, if I'm not using them regularly, I might not waste my memory space trying to memorize them. But if you know where they come from, they're very easy to get pretty quickly later. So tangent happens to be the quotient of sine and cosine. That's called the quotient identity, one of the identities you memorize. So since I know that and I have these identities already, well, I'm just going to take advantage of that and plug those in. So I've simply plugged in the formulas for sine and for cosine that we've worked already. Now this does look kind of intimidating, and I'm going to do a step that seems kind of odd, but you could do this many ways. What we're going to try to do is, instead of having this term right here, this one especially, cosine of alpha, cosine of beta, I'm going to change this term to a 1. You might ask, why would I do that? Well, honestly, you could write it many other ways, but often you'll see a 1 right here in the formula we typically use the most. And how would you get a 1? Well, you could divide this term by itself to get a 1. You don't want to only do it to that term because it would change it. So what we're going to do is divide everything, and we'll have fractions inside of fractions for just a minute, dividing everything by cosine alpha, cosine beta. So take a minute and pause and look at that so that I don't rush you. But you're dividing everything by cosine alpha, cosine beta to get a 1 in this lower left-hand position. Now when you've looked at that and it's starting to make more sense, I want you to kind of think about, well, why would I do that? And you might notice some things start to cancel. For instance, it's cosine beta, that's 1, anything over itself. Cosine alpha will cancel. And you'll be left with sines and cosines, and you know that that is useful for the quotient identity, so that we can rewrite this as tangent alpha plus or minus tangent beta all over 1. The signs will be different in the denominator because cosine changes those signs. 1 and then minus plus tangent times tangent. So you have a sum or difference in the numerator, and then you'll have 1 with the product of the tangents in the denominator. And this gives us our sum and difference formulas for tangent. So these are formulas that I won't ask you to work up every single time. You won't actually derive these formulas every single time, but instead you'll apply these formulas. And so you'll want to have these memorized for this homework assignment, and you'll want to know these pretty fluent. You'll want to know these formulas pretty confidently and be able to apply them.